So we're talking about the preparation.
Yeah.
Yeah. I'm trying to think this through because what I wrote down on my paper doesn't give me enough information. But somehow I came up with a negative 0.253. And
yes.
I'm thinking that's a Z-score.
That was the Z-score. So
okay.
Did you guys get 1 and 2 all right?
Yeah.
I guess the question I have on 2 is when do we know when we're just doing when do we know when we use the square root of n? Yes. What is the difference between the two?
Okay. So
that X bar, I thought, right?
Right. So when it has the bar X and the square root of n in it, the clue for me on those was when it has the probability of a random sample. We've been just working with probabilities of a whole of one population. And I believe, so I've done the homework for today, and it does go through and it says, like, find the distribution of the sample mean scores or whatever, but it says, so there's that one. And then it'll say of all of the samples, that's when you use the square root one with the bar X. The bar X to me so far seems to be the same as the X. I haven't found a difference in numbers as I've done that. It's the same number.
Okay.
I hope I'm not leading wrong.
I think that's what I finally
that's
came up with. So,
but so my clue is when it talks about the probability of a random sample, like the mean of the means, or a random sample of all the samples. That's when it's gonna pull, and you're gonna use the square root of the n.
Yeah. Okay.
Because you're gonna have an n in there. You're gonna have that. You'll have that fourth piece of the puzzle, or third or fourth piece of the puzzle to plug in. Other times we won't. So like on the Z-score for the sample mean that's normally distributed on this one, it's the sample mean, not just the Z-score for a normally distributed population.
Okay. So if there's the word sample or a random or and that's kind of what I had finally figured out.
That's how I figured it. And I'm gonna try to get back on tonight at 10:30, and if she'll differentiate for us on those.
It's tonight. I thought it was Monday.
No, it's not till Monday, right?
Monday. Yeah, sorry, Monday night.
Okay.
Yeah.
Okay.
So, but ask her to double check that. Because that is a question that I want to make sure I have right. To know which equation to use when is kind of important.
Right. Yeah.
But
so
I think when they use that word random, they are talking about that bar X. Because on the beginning, like if you look on the very beginning of the instruction, and down on the bottom, it'll say the mean of the random variable bar X. So and then the standard deviation of the random variable. So
where are you at? I don't even know.
Very front page of the instruction, the text.
Of our textbook.
Yeah, the textbook. I printed that off, and that's kind of what I was going by too. So what Christy's saying makes sense to me.
Yeah. So the random variable X is usually what you're looking for. Because this is like, the mean from the draws of the random variable with a mean U. Anyway, so the X so far has been told to us in all of the problems. So that's helpful. So did we need work on 3, I guess, is where we're...
Yeah, can we work on 3?
So did everybody get A?
Yes. I wasn't sure how to get it.
That one's the one that threw me, but watching the videos did help.
Okay, one of the things that threw me on this is when I checked and the homework told me, or not the homework, but so the answer sheet told us that, well, if you just use the 68, 95, 99.7 rule, and I thought, well, it didn't tell me to use that. And she told us that when it, like, in that meeting that she had before, she said, if it says use this, then you use it. If not, you use the probability applet. You don't use them at the same time. And so I used the probability applet.
Yeah.
And it did come out almost 68%.
How did you use
just barely over? So
how did you use the probability applet?
you had to find the 2 z-scores. So you
Which
use
is, how did you do that?
in between. So you take the values, the z equals the value minus the mean over the standard deviation. Just the first one we used, no square roots.
So you
And
did the
so
10 minus 15 divided by 5.
Right.
Okay.
Right. And that got you the second one. You have to do it also the
way backwards, right?
Backwards, yeah. So the first one I did, you have to do 2 times. So I did 5 minus 10 because it was in between 5 and 15. 5 minus 10 divided by the 5, which is the standard deviation. And then you do a 15. So I worked that all the way out and plugged that into, with the z-score, and plugged that into the applet.
So you got two z-scores from those 2 things?
Yes. Negative and positive.
Okay.
But if your z-score is a -2 or a +2, you know from that 68, 95, 99.7 rule that that's 2 standard deviations off of normal, either direction. That's what the z-score is. It's the standard deviation off of normal, right? So it's a -2 and then +2. And so that puts you at, no, it was just 1. Sorry.
Yeah.
That equals 1, not -2. Because 5 minus 10 divided by 5 is -5 divided by 5 is -1. And 15 minus 10 is 5 over 5. So it's 1 and 1. So that's 1 standard deviation. And so that is 68% falls within that, using the 68, 90, that rule. But if you plugged it into the applet, which is what I did, I plugged it into the applet and I only highlighted the middle section because it's asking what is between these 2.
Right.
So the middle part was blue. And then that's when I got 0.6827 in the top, in the area.
Okay. Okay, well, that's good to know. So then how do you figure out the 40th percentile?
Then the 40th percentile, highlight that the left side.
The bottom part.
Yeah, the bottom
the
part.
First thing, the first thing you have to do is highlight, remember, because we're working with percentages.
Yeah. That,
but
and
so
you're going to use so you use the negative, you're going to use the negative side because you're wanting the 40%.
Right. So what you do is you highlight that far left side, and then the percent 40 you put up into the area. So where the 68 was, that's when right there you plug in 0.40, and then highlighting the left side.
Right. Okay. And then your z-score is 2.253.
And negative.
Right, and negative
2. Yeah.
Right. Okay. Yeah, that's important to remember. Negative.
Yes.
Then you have to solve for x.
To plug that and solve it for the x. When you're looking for the percentile, that's the variable x.
And I just used that other calculation, that kind of shortcut that Mr. Wilkinson was showing us in the video. I just use that shortcut. It's a lot easier than solving for x.
What shortcut
so how do you use?
Oh, just the subtraction one?
So then you just take the standard deviation, so which is 5, multiply that by the z-score, and then add the mean back in, which is 10.
So take the z-score divided by 5?
Multiply by 5. Yeah.
Oh, multiplied by 5.
So 5 times a negative 0.253 plus 10 will give you the population percentage, the 8.735.
And I get the 5 because the standard deviation is 5.
Yeah.
So
yeah, it's just kind of
standard,
Sister Wilkinson showed this little process in that video, but I had already kind of backed it out and figured it out that way without having to solve for X.
And to me, it's just easier to solve for X.
Yeah, whatever's easier for you.
Yeah.
Yeah. I write it out because if and then I write out each step so that I'm trying to train my brain how to do it. So every time I'm writing out every step. Because I'm afraid of this test coming up. And
oh, I know.
So how do you solve for X? You just have Z. You put your okay. You just do it algebraically then.
Yes.
Yes.
So
okay,
I have
but then
negative 0.253 equals
X minus the mean,
which is 10 divided that whole thing, X minus 10 divided by 5, which is the standard deviation.
Okay.
Okay, so does anybody have questions on C? Are you still working that out, Sherry?
Yeah, but I can still work it out. Okay. Go ahead.
We know how to find the z-score for the observation of 18.5.
So there, just when it asks for what is the z-score, all we have to do is the formula z equals the value minus mu divided by sigma. Okay.
Yeah.
Okay, say that again. Sorry.
So just the regular z-score formula.
Yeah, just the z-score formula.
8.5 minus 15.
Minus
10
is the
divided
mean.
by 5.
Okay, right. 18.5.
Did we all get 1.7?
Yes.
So any questions on D?
Yeah, I don't know how to do that one either. Greater than 12. So it's the same thing.
It says the word probability in there, so that that helps you know you're going to have to use the applet.
Okay.
Yep.
So in order to use the applet, you need either a percentage, an area, or a percentage, or a z-score, which you don't have either in that question handed to you. So find the z-score.
So, okay. 12.
So your observation, last time you did it with an observation of 18.5. This time you're going to do it with an observation of 12.
Right. Okay.
And when you get your z-score, you need to plug the z-score into the applet.
Right. Okay.
And then it tells you that you have a probability of observation greater than that. So you have to, but you have to highlight one side. Which side do you highlight?
Would be the far side.
The far right.
All right.
When you plug in that z-score.
Right. 0.4 is what I got. Sorry, probably already. So the probability or the area is 0.3446.
Mm-hmm.
Yes.
That's right.
Okay.
Have a good day. Sorry.
Right.
Okay, then part 2. Is everyone ready for part 2?
Yeah.
Did you get E?
I got E.
Okay.
3.466. I mean,
That was
0.3.
D.
And the reason we have to add those two together is because it's talking about the probability of, we're talking about E now, the probability of what is less than and what is greater than. And so we have to add the two up to get that percentage.
Mm-hmm. Mm-hmm.
Is that right? Okay.
Yeah, you need both sides. Yeah.
Okay, so tell me, how do you do that again on E? I'm sorry, I'm partly sick and partly not with it.
Well, you just keep that same probability applet up because it should be up in there, and you have, so if your observation is less than 8, it's two off of the mean of 10 anyway. And so you've already got your far right highlighted.
Right.
So technically you could highlight the far left and the far right and it'd give you the same answer. But you shouldn't, since it's a normal distribution, they're going to be equal on both sides anyway. So you can just multiply it by 2 without having to look at the applet if you've already got that information.
Okay, so it's 0.6554 on the applet.
Yeah. Points. Oh, 0.6892.
892.
Yeah.
0.6.
Is your Z-score in at -4 and +4? 0.4?
Yeah, -4 and +4, and then if I highlight just the right, it's
And the left.
The right and the left. Oh, okay, I see. Less
But not the
than
middle.
8 or greater than 12. Okay.
The easiest way to do it is to just multiply that number by 2.
Right. Yeah, I see what you're saying. Yeah, okay. Okay, I'm good to move on to part 2 now.
Okay.
So suppose pair computing sold an average of mu 45 phones per minute in 2011 with a standard deviation of sigma of 10, and they looked at their phone sales data and determined that they are normally distributed. So samples of size n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X? And we know because it says in there normally distributed that the shape will be normal.
Mm-hmm.
Right.
Yep.
Good.
Even with your sample size doesn't matter.
And is that because of the central limit theorem?
Just because it says it's normally
Just a
distributed.
normal?
Yeah.
Okay.
Yeah.
Okay.
If
All
you have
it's
a right
asking-
skewed or a left skewed, then your sample will matter. Your sample size will matter.
Right.
And
Right.
then it would be because of the central limit theorem.
Yeah.
Correct.
And it's
Okay.
only and they only ask this question just for so that we'll make that identification between those, the normally distributed and
Right.
yeah.
And the skewed.
I actually highlight that in my question. Every time it says normally distributed, I highlight it right away so that I
yeah, when I'm reading, start to look, I kind of underline what, the pertinent data you need. So then you don't have to look at all the other words. You don't have to kind of sort through it. Underline
Right.
mu, underline, just kind of go through it like that and highlight it. Yeah.
So do we want to go through each of these, or do people just have questions on specific ones?
Well, let's go through each of them. Is that good?
Okay.
So did you have a question with number 5?
No, I did number 5
Just
too.
the same, right? Which like Joyce said, they're asking us this because the next question's going to be a right skewed, and they want you to be able to differentiate.
Yeah.
So doesn't matter what sample size you have, but we do have a sample size. So we have an n value, so that tells us automatically that we're going to need to be using the bar x and square root of n in our in our equation.
Yeah.
Okay.
Yeah.
So the sample size is 4.
You did number 6?
Yeah. So that's my n.
Correct.
And then,
So to set this one up, you're going to take your observed, your 40, minus your 45 from the setup paragraph, your clones. So your mu.
because 40, I want to
Yeah.
find out less than
Yes.
40.
Yes.
Why don't I
the
do
probability? Yeah, the probability that it's less than 40.
Okay.
So you're going to set it up, quote, 40 minus 45, and then divided by
the deviation of 10.
Yeah, the deviation of
Square
10
root of 4.
divided by the square root of 4. Yeah.
Okay.
Correct.
So that sets that one up that way. That gives you that z-score, or the sample z-score.
Right.
So the observed bar x is greater or less than or equal to 40, whatever that's, and it says what is the probability. So you're going to need find the z-score and then plug that in.
So is that negative 0.25?
And then put that into the applet.
Right. Okay. And how do I shade it?
What is the probability that the observed bar x is less than 40?
Okay.
So if it's less than,
it's going to be on the left side.
Yep.
Is that 0.4013?
So you should have come up with a -1 when you did to get your z-score. Your 40. Did you get the -1 and plug that in on the left side?
No, I got a negative 0.25. What did I do wrong?
Let's see. Get my calculator back open again.
So if you take 40 minus 45, you're just getting a z-score right now. So you're going to subtract 40 minus 45 and you get a -5.
Right.
Then on the bottom, you're going to take 10 divided by the square root of 4, which comes out as...
divided by, I did that wrong, okay.
Yeah, divided by the square, which comes up to 5. So you have a -5 over 5, which gives you a -1.
Okay, I get it now.
And then you go to your applet and put in that -1 on the left-hand side because it's less than.
Less than. And shade first, so -1.
Then you're going to get 0.15. I rounded to 9. Yeah, so 159.
Okay, thank you.
But then for the next one, you're going to need to do that again.
Twice.
Because you're looking for, you're looking
35
for
or 55. So, but this also goes back to, they said, like it doesn't tell you, but the standard deviations on these go back to the 68, 95, 97 rule.
Yeah, yeah.
Which they brought up
but you don't see that until you get through it a little bit. Yeah.
Yeah. And so, but, and I liked to just work it all the way out and then be pleasantly surprised. I just used that
the z-score, right?
My answer to make sure I'm, to make sure I'm close.
Yeah.
So with the 35, you work it out, and the 55, you work it out all the way down. But it says, what is the probability that it is greater than 35 and less than the 55? Your z-score happens with these to be plus and minus 2, which is the 2 standard deviations, which means you should be relatively close to the 95%.
Okay, I'm kind of lost. I'm sorry.
So, so for this one, the clue word here is your and, which also means between.
Okay.
So you're looking for that information, the between or the and.
Right.
And so you're going to have two calculations. You're going to have your 35 minus your 45
Okay.
divided by 10 divided by the square root of 4.
Okay.
So you start with that one. That gives you your -2. And then you get 55 minus 45 divided by 10 divided by the square root of 4 gets your +2. So that'll give you those two z-scores.
Okay.
And you can do it, and you can do it separately, and you can get one, and then add those two together. But this is, or you can just put your +2 and your -2 in, and it should give you that
area at the
top.
0.0455.
If you highlight in the middle section, right?
Yes.
Yeah.
Yeah.
And when you're doing this, to go on, not to jump ahead, but number 8 is the same thing, except your n has changed.
Okay, so
and your 41 and 49 changed. So it's the same principle with just different numbers. So you need to plug in your x has changed and your n has changed, but the rest stays the same.
Yeah.
Okay,
And
so
what
on
this
7,
one is, yeah.
sorry, on 7, do I highlight the middle section?
Yeah, highlight the middle and then put your -2 in, and the other one will just auto-populate and give you your percentage.
So it's 95. So that's kind of the same 68, 95, 99, 70. Okay.
Correct.
Okay, so then on 8, the sample size is 25.
Yes. So that changes.
Okay, so then I find the same 2 scores for that one like I did in the previous one.
Correct.
Okay.
And you'll probably want to work that out, but I'm gonna have to go before too long.
Okay, so yeah, I can work it out. What else do we need to do?
Well, with that one, I think what they wanted us to understand, because the probability between those is actually, like, it shrunk, or you had 20 points between 35 and 55 before. We had 20. So but our sample size was smaller on number 7. So number 8, our sample size got bigger, but the probability that they're looking for the values of that is actually smaller.
Right.
Yeah.
And they're the exact, they end up being the same answer. And so that's where we're looking at the theorems coming into play, and the law of, I was going to say the law of the land. That's totally not even where am I headed?
The law of large numbers.
The law of large numbers. So that's where those are they're showing you that with your sample size, the bigger the sample size, the closer you're going to get to that.
Yes.
Mean.
Okay.
So do we want to go ahead and do the quiz, since we can do it twice while Christy's here, and then we can all retake it or whatever, if there's, and keep meeting so Christy can go ahead and go?
Yes.
Yeah, can I ask you guys one question before we do that?
Yes.
You're done with all of the preparation? So on number 15, the answer key came up with a z-score of 1.056. Which was not my z-score.
Was it not 0.1056?
I don't.
On the preparation?
Yeah.
I didn't get that.
I didn't either. Mine was negative. No.
I got a negative. I got a 1.25. And a -1.
Okay.
Yeah.
Yeah.
Okay, but then so the z-score for 37.5 is a -1.250.
Yes.
And then for 45, it's a positive 1.25.
Okay.
So and then you're putting it in your app.
Yes.
Should have been. I got 0.7887.
Yeah. Wasn't that the answer? I thought I got that right.
Was the
Yeah, that's
answer,
right.
But I think that the answer key said that the z-score was 1.056, and the answer was that. So maybe I read it wrong.
I don't know,
no,
but
I
you know
think
what? I have seen a lot of mistakes.
That's what
the answer he does come up with the
Yeah.
the 0.7887.
Yeah.
Okay. Okay.
Yeah,
don't
but
have
I
the
thought
answer
it
key
had a
in front of
z-score
me.
in there first, but maybe I'm wrong. So the answer key sometimes has got a few little, usually the answer's right, but sometimes the steps are not.
Yeah, sometimes the steps are not. Sometimes there's, yeah. And sometimes
Well,
the dude on the video, the kid.
Yeah, he sometimes
Well,
says.
and so let me just ask this on the answer key. What it says is we have to take a 1 minus 0.1056 minus 0.1056. And that's where it comes up with the 0.7887.
Yeah, I don't know.
Okay, so they just did it the extra instead of just shading the middle and see what it was. They added the 2 tenths.
Yeah.
The 2/5.
Yeah.
Which is weird to me.
Yeah.
I have an applet. I'm going to use it and just shade what I need to shade.
Right. Right. Yeah, that applet's easier.
Okay.
But this one 15 is right skewed, so the applet wouldn't have worked for it.
Oh, that's true. That is true.
So I think I calculated this out. I don't think I used the applet. These last two,
had to have.
all these questions that were right skewed, we wouldn't have used the applet for that.
Right.
Yeah.
Now that I'm.
Yeah. Now that I'm looking at it and go, oh, wait a minute, this is right skewed stuff. So yeah. We would have calculated this out.
My mouse not working.
Okay. Thank you.
Mm-hmm. All right. So do you want to go do the test?
Yeah.
Guys, can we have some fried eggs or shrimp?
Scrambled.
Okay.
It says to round to 3 decimal places, but not until we're complete with our calculation.
And we're probably just going to need to open the applet now.
Yeah.
Combined area to the right. Are we all on the quiz?
Yes.
So does somebody want to read each question? Or does
So what are
everybody
we
want to just
shading? What is this asking? What are we shading here? To the right.
The right of
Looking for the outliers of.
Yeah, so the z-score
1.58.
is it's basically asking what's more than that z-score and less than that z-score. Right? So because to the right of a positive would be that tail, and to the left of the negative would be that other side. So I would say we're plugging in this negative or positive, doesn't matter.
Right.
1.35.
Plug in the outliers. Yeah. And we're looking for that area up top. The 175. That was, sorry, everybody there.
Yeah, that's what I got too.
1745.
But it says rounded to 3.
0.175?
Mm-hmm.
Correct.
Yeah.
I don't know this one.
I don't
Does this
either.
mean? Which of the following have a smaller standard deviation if 9 observations are randomly drawn from a population? So the
Probably the distribution of the sample means, right?
why would it's asking about a smaller standard deviation.
And I know this is in the notes.
There isn't a.
Is there enough information here to do
There's
this?
only 9 observations randomly drawn from a population. So we have the 9 randomly drawn.
Uh-huh.
So we don't have a sample of that sample, correct?
Right. That's what I'm thinking. There's not enough information here. Is there?
This is where I get tripped up with all the words.
I know.
I
the
know.
words. Would you have followed up a smaller standard?
When is the sample mean normally distributed? The parent population is normally, the sample size is large.
I don't think that it.
This is throwing me, but I don't think there's enough information here.
Yeah, that's kind of where I'm leaning.
Meaning, this is one.
Okay, so for the mean of draws, standard deviation of the random variable is bar X. I don't think we have enough information.
I don't think we do.
So should we put that, and then if we
I'm
have to
gonna
go,
yeah, I'm gonna go with that cannot be determined answer because I don't think we do. That's
results implied. Which of the following results implies that the spread in X bar decreases as the sample size increases? And that would be the law of large numbers, right?
size increases.
That the spread. You're talking about the spread in the bar X decreases as the sample size increases. So they're talking about spread.
As sample size, so the law of large number says that if the sample size increases, the sample mean bar X draws closer to the population, so it decreases.
So that means it gets more accurate. So in spread,
so the spread of the bar X decreases, so it does decrease. So it is more accurate.
Yes. So that is the law of large numbers.
That's what I would say. Are you others in agreement?
Yeah,
Yes.
we're good.
Yes. Yep.
I don't know. You get it.
So use the following information to answer the next 4 questions. Scores
Okay.
on the quantitative portion of the GRE are approximately normally distributed with a mean 150.8 and a standard deviation of 8.8. Diane earned a score of 160. What is the Z-score corresponding to Diane's score?
Okay, so let me just, on this one where it's just talking about the Z-score, all we're doing is solving
But you don't
for
have,
Z.
you don't have N on this one.
We don't
There's
have
no
an N, so
Right.
we don't have to use it
It's just a regular standard deviation.
because there's just one main population
Mhm.
with one mean, one standard deviation. There's no samples drawn from that we need to get.
Yeah, so you don't need the square root one. So you just need 1.0.
The 150.8 divided by 8.8.
160 divided by 150.8. 160 minus 150.8 divided by 8.8.
I'm going to have to write down all of these formulas better.
My problem is when are we rounding? Are you rounding to 0, 0, 4?
Round to 3.
Round to 3 after the decimal. So this one is just 1.045, right?
Yeah, wait, what? So what did you guys get?
1.045.
1.045.
So why did I get 0.105? What did I do wrong?
Did you put in your decimal
Invert your
8?
number? Did you invert your
0.8?
numbers? Or get your 0.8?
I think your decimal's just in the wrong spot somewhere.
So I got, okay, so 160 minus 150.8, I got it at 9.2.
Divide by
Divided by
Divided by
8.8.
Divided by 8.8.
Yeah.
Should have given you
yeah.
one. Yeah.
Okay, that's what I did, but I must have put it 0.8. Okay. So it's 1.045.
I like that it just says find the Z-score and you don't have to figure out what you're supposed to be putting in.
Yeah. Okay.
Okay, so that is the Z-score for the
For the next
probability.
problem. Mhm.
So that is, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Okay, so above, we're going to put in the 1.045, and we're only going to highlight the right.
Mhm.
Yes,
Mhm.
and not above. That's actually the Z-score.
Yeah.
So then the area is the answer, right?
Yeah.
So it is 0.0.
148.
Yes.
Nope, I'm not getting that still.
So
your
highlight
Z-score is
the right side.
1.045.
I changed my Z-score. It changed my Z-score when I changed. So it is a 1.045. So now my area is a 0.148.
Correct.
So it's 0.148.
0.148. Yeah.
Okay. That's what I have to watch, because sometimes when I change the blues on the applet, it changes my Z-score. So I have to make sure.
Right.
Okay, a random sample of 5 students was selected to take the GRE. Their scores are. Okay.
Okay, so this isn't giving us the sample mean. We've got to find the sample mean.
Yes.
Right.
This is Z-score corresponding to sample mean.
Oh,
So does everybody have the sample mean?
160.
Yes, that's what I got. Did anybody else?
Yeah, 160.
So our mean is
160. What is the z-score corresponding to the sample mean of these student scores?
okay. So now
Well,
hold
that
on.
would be that same number that we figured
Figured it
out.
out already.
Figured that one out. That's still,
Right. 1.045.
yeah, 1.045.
Okay, and that's because if we didn't know the information before, we would still just solve the z-score the exact same
Solve
way,
it.
right?
Yeah, if
The
it
160.
if it had come up with a different answer, then we would have just calculated a new z-score for that
A
one.
new z-score.
Yes.
But this one is 1.045.
Yeah, that one
Okay.
we figured out when we did question 6 above.
Okay. Okay.
You said that. I was like, that's so rude.
Okay, so what is the probability that 5 randomly selected students will have a mean score? So the mean score that is greater than the mean achieved by the students in the previous problem.
And that's the same
Okay.
one we did before with the, what's the probability that a student will score above that? We figured that one out before too, was the 0.148, right?
Well, now we have 5
What's the
randomly selected students will have a mean score. So it's a mean. Is this
The
when
mean
you
that
put
is-
in the square root?
Isn't it the same as number 7? What is the probability that a randomly selected student will score above 160? Isn't that the same in question 7? Because we're asking for what is the
Well,
probability?
this is the probability of a random sample of students in that.
Because
No, so
5,
you have
I'm thinking that we need to put in with the bar x and the square root of n, and n would be 5 because it would be 5 randomly selected students.
okay.
so we're
So
gonna.
then how would you do that?
So
You would do
is it going to be the 160 minus the 150.8 divided by the 8.8, taking the square root of 5?
That's what I think. Am I way off base?
I don't think so, but just the way, since they don't give you the thing. So what is the probability? So we know that n is 5. 5 randomly selected students will have a mean score that is greater than the mean achieved. So what is the mean achieved by the students in the previous problem was 160.
Right. So we solve for x minus 160.
X minus 1. Oh, no, x. So what is
We have
x?
X is
So
the
we
one.
have x. Yeah.
So x is 160, not the mu. X is 160. Yeah, so it is. It's just the 160 minus the 150.8.
No, because
No,
the mean of the new mean. Okay, so we have, what is the probability that 5 randomly selected students, which would be n, will have a mean score that is greater than the mean achieved by the students in the previous problem. The previous problem only had those 5 students, and their mean was 160.
Yeah.
The mean of the original problem
Was 150.8.
was 150.8.
So what is the formula?
Oh, but the mean we achieved in the previous problem was 160.
It does. It scores will have a mean greater than the score of the mean achieved in the previous problem, which was mean of 160.
160.
Which I think it just goes back to 7. What
So
is
does
the
this
probability
need
that
the
a
square
randomly
root?
selected student will score above 160? Oh, but 160 is our new mean.
I think that we're going to have. I don't know.
Do you think this needs the square root? Are we calculating it out
I
that
think
way?
so, because it says random sample.
Random
the
sample?
probability of a random sample.
Mm-hmm. So we're still going to take all the same information, the 160 minus the 150.8.
I don't think. Well, it's got a new mean score, because this says greater than the mean achieved by the students in the previous problem.
That's not going to work out right. Hang on a second. Let me calculate
So you
that.
have the X, the bar X, which is 160.
That's not going to calculate to anything. You'll get a 0.
160 is greater than.
Because if you put 160 minus 160, divide that by 8.8, divide that by the square root of 5, you're going to come up with 0.
I don't know.
What is this problem saying?
What is the probability? That's what it's asking for. And there was a problem on the homework that said,
At 5, here's my homework for something close.
okay, number 9
On the homework
or the preparation that says the sample size N25 is taken. What is the probability that the observed X is greater than 50? Is that kind of like what we're doing? How did we get 9 on the preparation assignment? I forgot already.
That would have been the square root problem. You would have solved it with the square root.
So the square root of
with
5.
Square root z-score. Mm-hmm.
My question is which mean do we use?
Okay, so
the 160 that we just got.
Okay, what is the probability that 5 randomly selected? So 5 randomly. Let's walk this through slowly. 5 randomly selected is your n, right?
Mm-hmm.
Okay, so put that in your. Okay, so that's just to write this all down. We'll have a mean score that is greater than the mean achieved by the sample students in the previous problem. So greater than 160. So is that the sample? So that's the mean of the mean, which is the same number as the previous mean. I don't think we're going to change it. So the sample, so the mu bar x is equal to the mu.
Which is 160.
Which is 1, yes.
Is it 160 or 150.8?
No, it's 150.8. Because all we did, that 160, all that 160 is the mean of those 5, right? It's not asking for the mean of the, okay, let's see. What is the probability that 5 randomly selected students will have a mean score greater than the mean achieved by the...
So greater than the 160.
Uh-huh.
So how do we do number 9 on the preparation again?
Because the problem is you're either going to get, it's either going to be 2.34 or it's going to be 0. Because you can't, if you take 160 minus 160, divide, yeah, you're going to get 0. Divide by 8.8, divide by 5, and the square root of 5, you're going to get 0. So there's a big difference in between how we're interpreting this information.
So explain to me how we got number 9 on the preparation assignment.
So, okay, so number 9 on the preparation. So we knew the sample size, we knew the n, which is the same. We know the n here. We knew n was 25. It was taken from normally distributed data. We knew that. So we had the 45 above. Where did we get the 45? From the problem set.
It was from the
in the phones. Okay, from the problem itself. So we took 50 minus 45, divided that by 10, which was the standard deviation. Divide that by the square root of 25, because that's our sample of our sample. So that would have given us 2.5. And then when we plug 2.5 into the probability applet, that would give us 0 or 0.0062. So the probability that it would be greater than 50 is really small, is 0.0062.
So can't we do that same thing here?
We can, and we need to. The issue is we don't know what numbers to plug in where because of the wording of the problem.
Yeah, so we're still trying to sort out what
Because it doesn't just say the mu equals 10.
Yeah.
Like all of our other problems.
Yeah. So what I'm trying to figure out here is, are we looking at mu bar x, which would be the mu of those randomly sampled ones is the same as the mu. So looking at that, you know, when we did those samples with, what is his name? Kremer or I can't say his name. He talks so fast. Cromar. That's what it is. Cromar. Okay. He said the sample. So the mu bar x is equal to the mu. And we were doing those human pregnancies, remember? So he would say the mu bar x is equal to the mu, which is equal to 266 days. And then we took the standard deviation bar x, which is equal to the standard deviation divided by the square root of n. So just going by that formula, I'm saying use the 150.8.
150.8.
Yes.
What about how do you compute the standard deviation with the z-score? Because we just found the z-score in question 8 of 1.045. Then how do we compute the standard deviation for that?
So this is that same formula where you're using the square root z-score for this.
So our mu is the 150.8. The standard deviation is 8.8.
Yes.
N equals 5, and then the x is 160.
Well, so this one doesn't really have an x. So you're just going to use what we have right here is we have the mean of the mean, which equals the mean. And then we have the sample size of we have the standard deviation. That's the same standard deviation. So those things don't change. So it's kind of funny. They give you all these little figures and things, but some of it doesn't change. Really, the only information that we need to know is what was the sample of the sample. So we need to know n, and that was 5.
Okay, but if we don't know x, you can't solve for a z-score.
What is the probability? That's what we're going for.
Well, you solve for it because we're looking for greater than 160. So we're going to put 160 in there. And then because this is a normally distributed.
Because 160 is the mean achieved by the students in the previous problem.
So we don't actually need an x here because we have some knowns already.
Okay, so tell me the formula then I don't know how to solve for that.
So I'm thinking it's just 160 minus 150.8 divided by 8.8 divided by the square root of 5.
Okay, well, and I think that's
honestly,
that's what I said, but is x, so okay. Yeah, I think we're saying the same thing in different ways.
Yeah, I think we are.
And I'm the only reason that, honestly, that's the only thing I can think of to do that we have the numbers for.
Right.
Because it doesn't work any other way, but it is not. I'm not understanding the wording.
I am not either. I need to ask Sister what this means, because this is not, it's not coming out right. And if it's asking, what is it asking again? Is it asking for the probability?
Yes, so we have to have something to put into the applet.
And so I would say put 2.34, shade the right side, put 2.34 into the applet, and the answer.
Because have you already solved for Z?
Yeah.
Because I'm still, okay, so I'm still solving.
Yeah.
Me too.
Because I was trying to figure out, if you put a 0 z-score, what is that? That's not going to work, right? You put 160 minus. That means 50%. If you did it that way, 50% of the students would get above a 160. And 160 is pretty high if the mean is one. I mean, it's just logically, it didn't make any sense to me to do it that way.
So what did you?
Totally lost.
Yeah.
Okay, so let me go a little bit slower, just to kind of how I processed it in my mind. We were thinking if to use that same 160 mu from the other group, which would have mean we set up the z-score for the 160 minus 160 divided by 8.8 divided by the square root of 5, which would have given us 0.
Right.
So then if you take that 0, you're looking for greater than, more than 160, you put 0, you shade the right side, put 0 down in the bottom z-score, then the probability applet is going to tell us that more than half will get above 160, which
50%. Yeah.
50%. And that can't be. That doesn't, yeah, because 160 was already way higher than the mean anyway.
But the new mean, we just got a new mean from the previous problem.
Yeah, so I'm saying don't use it. Don't use the one. Don't go 160 minus 160. Don't do that one. Just use the regular mean from the original problem.
So you're going to take the 160.8? Yes.
Yes.
And that gives you 9.2.
Yes.
So then when you do the bottom half, what did you get?
Okay, so then if you take 160 minus 150.8 divided by 8.8, because that's a known. You just leave that, and the sample of the sample is 5. So divide by the square root of 5. That would have given us a new z-score of 2.34.
I have 2.338, but yeah.
That's what I put too, just because we're rounding out.
Yeah.
Okay. 2.338.
Which I plugged into my probability applet. And it gives me, and I only shade the far right.
Only shade the far right.
So I get 0.0097.
Yeah.
Yeah, that's what I get too.
Yeah.
All right. Well, let's move on because we can go in circles all day.
Oh, yeah.
Yeah, and it says to 4 decimal places, so that.
Yes.
Yeah. That was hard. That one was hard, sorting that one out.
I don't like story problems.
I don't like it when they try to kind of confuse the data it makes it harder. Okay, so.
Okay, suppose the mean GPA of students 3.5. So we have a random sample. And it's left skewed.
Standard deviation.
Okay, so this one, we start with a left skewed sampling distribution.
This is a really big sample.
But we have a huge sample, yes.
Oh,
So
okay. We'll read the question.
But then that's going to get it closer to, this is the law of large numbers, right? So it's going to be approximately normal?
Right.
Yes. Okay. So what is the mean of the distribution of the sample mean?
Mean of the means.
Oh, hold on. My computer just.
So the mean of the mean is the same. It's always the same as the sample. Yeah.
What your computer just do?
But that's what we're looking for, is the mean of the means.
So isn't that 3.5?
Yes.
So 11 is 3.5.
Yes, that's
is
still
that what you guys would put?
Yeah,
yes.
Because that's still 3.5.
The standard deviation
of the sample mean. And the standard deviation is still the same, so it's still 0.07, right?
And then you're going to take the square root of 81.
And then we're going to get down there to that.
Are you on 13 right now?
5,
Mhm.
12 is what I'm on. Are you guys on 13?
Uh-huh.
Why would you need the square root of 81 for 12?
Okay, so it says, what is the standard
For the
deviation?
standard deviation
And to solve a
of the
standard for all possible samples. So that is, so we know that in these, that the mean of the means is always just given to us. It's 3.5.
Right.
The standard deviation is 0.07, but to get the standard deviation of all possible samples, you have to take the square root.
Square root
if I can find
of 80. Okay, so you do the 0.0.
standard deviation of the random variable x is.
Wait a minute. What is it asking here? The standard?
So to get a standard deviation, you have to take the original standard deviation, which is 0.07,
0.7 divided by the square root of 81.
The square root of n to get the standard deviation of a sample. Let me see if I can find where that says
that's still the
I have where it says standard deviation of the random variable bar x is, and then it is the standard deviation divided by the square root of n.
Yes.
So,
and that's as far as we.
The random variable. What is the random variable x in our problem then?
Are we on 12?
Uh-huh.
Yeah.
Okay. What is the standard deviation of?
Standard
so
deviation
it would just be
distribution.
0.7 divided by the square root of 81.
Uh-huh.
Yes. That
0.07.
Yeah.
Yeah. So 0.008 if we round, because it's 0077.
Okay, let me do that again. I mean, that's what I did, but okay, so you take 0.7 divided by the square root of 81 equals, okay.
3.
So that is 0.078.
0.78.
So 0.078. Okay, so were we saying the same thing? I guess I'm not sure what the confusion was.
Okay, yeah, but it says, but we're rounding to 3 decimal places, so aren't we going 008?
0.078.
No, I have 0.0077. There's 2 zeros, right?
No, just 1 0. 0.7 divided by 9. The square root of 81 is 9. So it's 0.7 divided by 9.
So 0.7 divided by 9.
It's not 0.7, is it?
Okay. No, that's why I said that same. Yes. Okay. Sorry, my bad. I plugged that in wrong. So it's still the same. It's still the same standard deviation in the problem. The 0.0.
Yes.
Yeah. Okay.
Well, in the problem, it says it's 0.7. And we've come up with 0.078.
0.07. Okay.
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 Next.
All right.
Are we almost done? So Christy can be on her way?
I'm sorry, Christy.
Sorry. We're getting there.
Okay, so let's read it out loud. What is the probability, and let's write it down as we go. So what is the probability that the mean GPA, so the mean we know is 3.5 for 81 randomly selected BYU-Idaho students.
Bar equals 81,
no,
right?
We don't. Well.
And it'll be 81. Well, let's read the whole problem. Okay, what is the probability that the mean GPA for 81 randomly selected BYU-Idaho students will be less than 3.3? Oh, I hate these. Okay, I thought I was getting it, but now I'm like, okay, no, I'm not.
Oh, no, so this is just 3.3 minus 3.5 divided by 0.7 divided by the square root of 81.
So
Right?
let's give all of the information. So the mean is 3.5. The standard deviation is 0.7.
Yes.
Our X
Or
is this.
the N is 81.
The N is 81, and the X, this bar X is
Okay, you guys are
3.3.
getting really
No.
Getting what?
Are you there?
So what you have your, like when you do your z-score, you have your, what were those terms? The variable minus the mu, right? Minus the mean. Right? When you do a z-score, you have the variable minus the mean. And the variable is that 3.3.
Right.
Yes.
Okay. Yeah.
So then we have to take, so to set up the problem, it's going to be 3.3 minus 3.5 divided by 0.7 by the square root of 81.
Uh-huh.
All right.
So that gives you your, okay.
Negative
That's going to take me
2.57.
7.1.
Then you put that into your.
Okay, and
is that norm? Okay.
I'm not even there yet, so sorry.
Is this skewed
the
anywhere?
standard deviation we already figured out from above.
We did?
Oh, yes, we did. Well, no, but this is.
But
This
that's
is
why
no,
I wondered if we did the one above correctly then.
No, this is different. Because now we have a different variable with the 3.3 in here.
I know, but the bottom where just the bottom half of that equation.
Yes, that part we do know from above.
So 0.078 is the standard deviation?
Well, that's the bottom number. Up top you have, so now you have a negative.
What bottom number are you talking about?
0.2, right?
So my equation is 3.3 minus 3.5 divided by 0.078.
Oh, you need the 0.78 in here?
You don't have the
just
0.7.
figured that out. If you're doing 0.7 divided by the square root of 81, we already figured that out in the last one. So that's why I'm.
Okay. So I'm confused here. Why would we use that other? Why would we use the 0.078? Because we.
Okay. Does your equation say 3.3 minus 3.5 over or divided by 0.7 divided by the square root of 81?
Yeah, that's what mine is too.
Okay. So, but the bottom half of that we just figured out in number 12. 0.7 divided by the square root of 81. We already figured that out.
So you're saying just take the 3.3 minus 3.5 divided by 0.078 and forget the square root?
That is how it would work out if we were correct in the last two questions. But I'm not honestly 100% sure that we're right on either one of them.
Did you come up with negative 2.571?
Haven't done that part yet. I'm just still going. I guess I'm wondering why I don't know. I'm trying to figure out the course designers and why they give us problems that are confusing.
A lot of these questions are really confusing.
Probably not.
See, I'm looking at what I'm looking at those equations that we practiced in the video and how he set it up. And so if you take the mean of all means and you take the standard deviation of all standard deviations, those numbers are the same. We don't change those. And I know sometimes some of the problems kind of layer on top of each other, but I would have still used that standard deviation and set that problem up just like we normally do when we're doing a z-score for square root.
Yeah, so that's why my question is on the last one, did we need to do the square root of it, or should we have just taken it right out of the problem?
That's what I don't know about that. I can't.
It's slightly different.
Yeah.
If you do it the way Christy says, it's negative 2.564. If you do it, if you recalculate it with the 0.7 divided by the square root of 81, 3.3 minus 3.5 divided by 0.7 square root 81, it's 2.571. So they're really close.
Yeah,
No.
they're close.
I still got this. So you have a negative 0.2 divided by 0.078, and
Whoa,
that equals.
where are you?
So if you take still back to where Sherry was, if you take the 3.3 minus the 3.5, you get a negative point.
I guess I'm trying to figure out how.
Yeah. I don't know how you're plugging yours in because I don't know what kind of a calculator you have. But I just put 3.3 minus 3.5. You know, do you have a split, one of those where you can put the like when you're doing fractions, you can put a number on the top and a number on the bottom in little boxes? Do you have that? I don't know what that's called. But if you plug it in that way, then you don't have to worry about where your parentheses and things are.
So what did you guys get for the z-score? A negative 2.564?
571.
I got 564.
564.
A negative 2.564?
I got both when I did it both ways. I mean,
Yeah.
I got 2.571.
Yeah, I don't know which one we're using. That's the problem that I'm having here.
0.005, right?
I don't know why we're using the z-score from above. I don't.
That is what it is.
The z-score, we're not using the z-score. We're using the standard
0.7. Yeah, sorry. It's like 0.7 and the square root of 81. It's the same number. So in number 12, we took 0.7 divided by the square root of 81 and got 0.078.
Mm-hmm.
Correct? So
yeah,
it shouldn't be different. That we shouldn't be getting different numbers, because if we have on half of our equation, the bottom half is 0.7 divided by the square root of 81, that part of the equation is identical to the one above it. So we shouldn't be getting different numbers.
Somehow that computation doesn't work then. I don't think you can, I think you need to follow the same. I don't think you can, because if you
I do it this way every time, because my calculator doesn't, like if I type in square root of something, it literally gives me square root of that something. It doesn't work. So I have to figure them out in separate steps, and we haven't ever had this big of a discrepancy.
But either way, it's 0.0051 or 0.0052. And if you're rounding it to just 3 decimals, it's 0.005
in the
either way. If it's 2.571 or 2.654, you're still getting your probability of 0.005.
So when I did it, Christy, when I do it your way, I get with, and because we've already done the square root part, so I just take the 3.3 minus 3.5 over the 0.78. I will get the negative 2.564. But if I use the mean of the means, which is how Brother Cromar set the problem up, that's when I get that little bit of a discrepancy. And I was noticing when we were, in the homework last week or with 7, that you get off by just those little bits, and the computer knows it, and they'll be wrong.
However, but the probability applet is so close. That's what Sherry's saying, because I just plugged them both into the probability applet, and if we round it, it's the same thing.
Okay.
They both come up to the same. So I put in 2.571, and my probability is 0.0051.
Okay.
But if I change my z-score to 2.564, which is what I got, then my probability is 0.0052. Still rounds to 0.005.
So 0.005. Okay,
so technically we all get the same answer in the end.
Okay, so in theory, this works because when you use the applet, we're getting close enough. I think
Right.
where we would get hung up, and we need to ask Sister Wilkinson about this, is if this was skewed one way or the other, left or right, we would need to know which way to solve this problem. So for this one, I think we're safe because what we're really looking for is 005, right?
Right.
So everybody's in agreement then that it is 0.005.
Yeah.
Right.
Whether that's the right answer or not, we don't know, but we're in agreement that it's the answer we all got.
Yeah. Well, just based on the two different calculation processes, we're good there.
Yeah.
Oh, sorry, you guys. This one has been hard.
Okay, so we are on number 14.
Wait. So, well, I take that back. So that says less than 3.3. So it's not really.
I think I did greater than. Did you guys?
I did greater than, but.
Oh, I did. I just did less than.
Oh no, I did do less
and
than.
And it is the same.
Yeah.
I actually did greater than, so I had shaded the far right, not the far left.
But that's what problem. That's going to be the same thing, right? Because problem 14 is that way.
And that's our next question, right?
That's the next question. So put the
0.995.
The rest.
0.995.
Mm-hmm.
Okay, now do what? Is it not the same?
No, if you shade everything above.
Everything above the line.
Oh, greater than, not greater than 3.3. The 3.3 is what we solved for. So now we have to select the middle and the far right.
Yeah. So this
that's what I have to remember.
9949, 999. So
0.995.
Right.
Mm-hmm. Or we can just take 1 minus the last number and come up with the same.
Yeah. Right.
Right. Yeah.
Okay. Question 15. Somebody read it.
I'm really worried about our test now.
Me too. I even just this homework quiz test. I mean, the next one. Okay. So the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. So let's write down the mean as we go along. Is that okay?
185.
Okay. So mean is 185. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boats, so N is going to be 48.
Mm-hmm.
Commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability. Maybe we need to read the whole thing before writing down. The sample mean is X bar. Oh, yep, you're right. Sample is X bar is 177.6. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Round your answer to 3 decimals.
I think we're not going to get all carried away by all the extra data that's in there. So just take the numbers and do this in a logical process. So 1776 minus the 185, right?
Right.
Divided by 26.7 over the square root of 48.
Mm-hmm.
That's where everybody has it. All right. So give me a minute to solve.
Yep.
Does everybody have the top answer?
Yes.
Is that a negative 7.4?
Negative 1.92.
Where did I come up with a negative? So it's 177.6 minus 185.
No, it's negative 7.4.
What'd you get?
Yeah.
Hang on, let me try it again. Hang on,
Okay.
let me try it again.
Okay.
So, 7.
Negative. Okay. 9. So negative.
What are you getting?
A negative 7.4. If you take 177.6.
You said just the top line.
Yeah, just the top line.
Oh, okay. Sorry, I've already worked mine all the way through. I don't.
Yeah. Oh, you don't do it that way, do you?
No, because so what I've got is already the Z-score. So work it out till you get the Z-score.
Okay. Okay, and I've got a Z-score when everybody else does.
I do too.
And the probability, so I got the Z-score of negative 1.920.
Yeah, that's right.
And then
negative 1.920.
Yeah.
And I got a negative 1.918. Why? Okay, so Christy, I think you work it out the same way as I do. Your top is a negative 7.4. And your bottom was at 3.858?
At 3.853.
Okay, let me do it again. 26.7 divided by the square root of 48 equals 3.85. I skipped the 3. So 3.853. Or did you go 4?
I just did 3, 4. Actually, I did the whole thing out and then I rounded it at the end, but.
Okay, so give me just a second. Sorry, guys. Okay, so we've got a negative 7.4 divided by 3. Okay, so now I've got a negative 1.921. Is that what you rounded to?
Yes, that's right.
All right, so we've got a negative 1.921. Okay, and we are looking for
the probability.
The probability of what? Is it greater than, less than? Where is
greater or less?
It's either above or below. So are we looking in the middle?
Yeah, so you shade 2 sides and leave the middle blank.
Oh, shade 2 sides and leave the middle blank. I did it the opposite way. So.
Okay, well, it says that they'll have a weight that is as extreme or more extreme, either above or below the mean. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones observed, but also values that are as far away from the mean as ours in the positive direction. So I would say both sides, not the middle.
Right.
Both sides of the middle.
And I was kind of expecting it to be like a 0.0543 negative 4 or something to extreme.
Like a lot smaller than that, but it's not. Mine just says 0.0547.
Okay, so then it's
0.05.
0.055 if you round it to 3 decimal places, right?
Yep.
0.055.
0.055.
So is it bad to write down all these answers before we submit it so that we don't have to work all of them when we retake this quiz?
Oh, you can pull up another.
Pull it up next to it.
Yeah, pull it up side by side from it.
Oh.
You can keep this quiz open and and then just open up a whole other screen.
A whole other screen. Oh, yeah. Okay.
Yeah.
Okay.
All right, are we going to get brave now?
Because I'm not feeling real confident about this one.
Oh, I know.
But let's see. We might as well go with it.
Go with it.
Why is mine not
happens? We missed 2 of them.
Well, that's not bad. What 2 did we miss? I missed
8.
We missed.
We missed that.
We missed 8. Yep. And
8, and then the one where we had the X question, the very first one, we had a question.
Which was the distribution of the sample means.
Yeah. Okay, we'll be quiet.
Okay. Well, I hate to leave you, but I really gotta go.
Yeah, you do.
Okay, go ahead. Yes.
Thanks, Christy.
Thank you so much. Enjoy your day.
Next Tuesday at 7 a.m.
Yes.
Yeah. That's good.
Okay, great.
Thank
See you then. Okay,
Okay.
so are you girls still on, or are you?
Yeah.
So what ones we missed?
So we missed a question
4,
4 and question 8.
7, and 8.
So all those ones that we were fighting over, I mean, fighting in our brain, not fighting each other, but
yeah,
we got
yep.
those all right.
Yeah.
Those
Oh
ones-
man, I am.
those ones we wrestled with, we got them right.
Okay.
So, okay, so what we need to do is rethink this question 8, but I think question 1, or question 4, I mean, sorry, we're going to bump that to the middle one, the distribution.
Yeah, the distribution of the sample means.
Okay. Oh my word.
So then, do we want to look at 6, or are we?
Yeah, I need to look at number 8 again and see where we are, how we're processing that one. Sorry, my dog's
Number
crying.
8? That's not, I don't feel like that's the one we were arguing over.
No, it wasn't.
No, it wasn't. It's funny because we went back and forth so many times on all the other ones, but this one, we must have not solved this one right. So did you take all those numbers, add them together and divide them by 5 to get a mean?
Yeah, and you got
Why would we be off there then? That seems strange. Sorry about my dog. Cleo, shh. 1, 6.
So divided.
So what are we punching in? The z-score equals 1.
So
Yeah, and that's what we did. So the z-score equals 160
minus,
what was the?
so what is the z-score to this?
was 160 minus 150.8 divided by
So because it's a random sample of 5, did we not take the square root of 5?
So what's the standard deviation?
1.05. So what were we supposed to round this to? Round it to 1.0.
So the only thing I can figure is we should have, I feel like maybe we didn't take the random sample of 5, our n equals 5.
This isn't so what is the z? Okay, so a random sample of 5. Okay, so we should have used, because it says random sample, we should have used the other equation. So let me see if we plug that in differently. 160 minus 1.
I've got 2.33, but is that right? Am I supposed to put that in the
8.8 divided by the square root of 5?
probability?
So then we should have gone 2.337 or 338.
Yeah,
338.
into the probability output.
No, because we're not finding the probability.
We just need a z-score. That's all we needed, right?
So the z-score should have just been I guess the 2.338. I think we just didn't go back up and put it.
Yeah.
Okay.
Yeah.
So, holy Toledo. I think usually if I get, a decent grade on these, I won't go back and redo it. But because I'm a little worried about the exam, I think I better get as many points as possible.
Oh
gosh. Okay. Well, are we done for today?
Done, or are we gonna, want me to stop the
I think we can probably stop the recording.
recording?
Yeah.
Yeah, you can.
If we have other